See. All right. So here's the thing. Let me take you back in time. When you've got difference of two squares, basically you have something like this. You've got, say, let's say x to the power of n. It must be minus. You basically have two terms separated by the minus, like that. All right. So difference of two squares, it's not, I think by now you should know because university. It's not difference of two squares because it has the power of 2, 4, 6, 8. Any power can work. So when you factorize that, what's happening? You're going to you're taking actually the same thing. Let me duplicate it twice. I'm going to duplicate that. So to factorize that, you've got 2 brackets, you got that, and you've got another one there. It's the same thing. One is a plus, one is a minus. But what you're doing, those exponents, you are dividing them by 2, but in a true sense, you are basically taking a square root here, square root here, square root here, square root here. Can you see that?
Yes.
That's what it is. Or to take a square root, it simply means I'm dividing the exponent by 2, or I'm multiplying the exponent by half. It's basically that. That is difference of two squares. Let me give you the one you're just familiar with, just to make things straightforward in your mind. If we were to give you x squared, let's say minus, let's say, let's make it p to the power of 8. That is difference of two squares. If they ask me to factorize that, I just take the same thing. It's because most people, they don't know what's happening. They just don't know, but I just know this is how it's going to look like. But I'm saying, what's the process? What did you actually do? So we repeated the same thing. One of them, we made it a plus. And then we came to that 2, or to this one. We took a square root of that. You took a square root of that. You took a square root of that. You took a square root of that. Do you see that?
Yeah.
All right. When you take the square root of the x squared, well, it's basically dividing by 2 here, dividing by 2, and even the other part. So you won't write the 2 anymore. You'll just write it as x because the 2 has now become 1. The 8, it will now be the power of 4. And then same thing, the other part there, it will be that. Even the next one, it will be the power of 4. Do you see what I'm saying?
Yes.
It doesn't have to be nice number. Let me give you a crazy one. Let's say you're given x minus y to the power of 3. It is difference of two squares, even this one. Difference of two squares need not to be the power of even numbers. So that means you're going to take the same thing, repeat it twice, and then let me put that in brackets. One of them must take a plus. And then what you do, you just take a square root of that, square root of that, square root of that. The reason why at school they use the power of 2, it's because the 2 goes pretty good, nice. It leaves no remainder. Yeah. So this one will be to the power of half here. This one will be 3 over the 2. This one will be power of half. This will be 3 over the 2. So even the last one here, this one, the one that I'm pointing at, that has a minus. You can still further do difference of two squares. You divide it by 2 again. It's infinitely. Okay, I know it's saying 10 minutes. Yeah. All right. So you see, I left it with fractions, but somebody can do this. They'll say, no. The power of half, it's actually the square root. That one would have been the square root of that. You see that? They can leave it in radical form. All right. Now that I've showed you this one. So here's what I want you to understand. Look at that power. It's a third. Hold on. So difference of two squares, how are you going to know you need to do the difference of two squares? It's when the exponent has the power. In other words, the exponents, the powers, they've got divided by 2, because that divided by 2 tells you square roots. Square roots, that means, oh, that was difference of 2 squares. Square root, square root. Can you see that?
Yes.
Yeah. So normally, I'm telling you ahead of time, normally, once you see there is 1 over 2 or whatever over 2 as the exponent, it means they've given you this part here. Either this one or the other one. That one or the red one. They're giving you the blue or the red one all the time. So all you need to do is to say, wait a minute, if you gave me the blue, I know what the red should have been. It should have been the one with the minus, or vice versa. Are you catching what I'm saying?
Yes.
Yeah.
Yeah.
Good. I gave you for the square, for difference of 2 squares. Now I'm giving you for sum and difference of cubes. With the cubes, normally you have a, let's make it a to the power, I'm going to use n, same story I did before, and then minus the b. Remember, it might be minus or plus. This is for the cubes. So with the cubes, the first part that you do square root of this one here, of the first one. So that means you're having a to the n minus b to the m, but you are supposed to square root them. And I'll give an example after that. So that means they'll be like over 2, like over 2. Then the next part to finish up the whole story. Yeah. Because it's big bracket and small brackets, like we say. It's a trinomial by a binomial. So what happens, this one, you now take this one, you square the first. You see this first one, you square it, isn't it? Yeah, no. I made a glitch. Let's go back. We're doing cubes. I must not divide by 2. I must divide by 3, sorry, because we're taking not square root, but cube root. Sorry about that one. Let's reverse and fix it. You are actually taking cube root, I meant. Cube roots, yeah. So this means there'll be all over the 3, all over the 3. Good, yeah. Now the pink one says, you're going to have to square that first term, meaning that exponent, you're going to times it by 2. So you're having a to the power, it will be 2/3 n. And then you multiply this middle term, these terms together, and then you switch the sign. The sign will be plus, it's going to be a to the power of n over the 3 times by b to the power of n. I'm using m over the 3. It'll be like that. And then now you square the last one. So the last one we already know is going to be plus. Let me shift this again one more time to the other side. Okay, I need to pull everything. All right. And then it will now be plus the b to the power of 2/3 m. Close the bracket. So what they're going to do, they're going to do exactly the same thing. So they might give you this blue one. You need to introduce the red one, or they give you the red, you introduce the blue. Now, to remind you this rule, you know it in this manner. If we're to give it to you as x to the power of 3, let's use a minus still, because with the cube, you can use minus and plus, and then that. You normally say this is the same as x minus the y. But I said, how in the world did you get x minus the y? You took the blue as it is, as it was, like that. You took the cube roots. You took the cube roots. Can you say that?
Yes.
So in other words, you divided the powers by 3, all the powers by 3, like as I did here, because here they remain because 3 cannot go into those ones. So that's exactly what happens. So you have that. Then the pink part that's coming, you took the yellow, you squared the first one. It became x squared. It becomes x squared, and then you had to multiply the x by minus y, which is minus xy, but you change the sign, you make it xy. And at the end, it's always plus again. then you square the last one, which is y squared. Do you understand what I just said now?
Yes.
Yeah. So how in the world are you going to see these guys? You're going to see them giving you something in brackets to the power of half, or something in brackets to the power of a third. In other words, the key is what at the bottom here. That 2 tells you it was difference of two squares. That 3 at the bottom tells you whether it was 7/3, what it's some 1/3, 2/3. It told it was that cube 1. Are we okay with that?
Yes.
Yeah.
Yes.
So it's the same thing what's given here. You see what's given here? Because it's two terms. They gave you this white part. You need to do the pink portion. You finish it up with the pink portion. You conjugate it with the pink portion.
Okay.
Remember when we were saying you were conjugating, you had this one. Remember difference of 2 squared, you had the one that has a plus. You needed to use the other one with the minus.
Mm-hmm.
Like how you factorize. Quickly, let me remind you, chap. You had x squared, let's say, minus 4. You'll say, well, to factorize that dude, I actually need x plus 2 and then x minus 2. You had to make this one in red to be together. Do you see that? When they give you plus 2, you use the remaining portion, the remaining part of factorization, the remaining factor that was not given, the minus
Yes.
2. Yeah. It was not really to, let me not use the word conjugate or rationalization. It was really remembering the factors, how they partner together. They give you one of them, you must find who was the partner really. So here it's with the cube. If they give me this one, the one that I'm pointing at here, what is its partner? The partner is this one here. That's like you do it for top and bottom. I think you got it.
Yes.
Are we good?
Yes.
All right.
Yes.
Because I can see now it's a cube. That's what we are going to do for this one. All right. So let me stop this one because